Hey guys, welcome back. So let's see the next question. Differentiate between univariate, bivariate, and multivariate analysis. So what's the answer for this? So in analysis, we usually come across this three terms: univariate, bivariate, and multivariate. So let's uncover the meaning of them. So univariate data consists of only one variable. Okay, the analysis of univariate data is the simplest form of analysis since the information deals with only one quantity that varies. It does not deal with causes or relationships. The main purpose of this analysis is to describe the data and find patterns that exist within it. The pattern description found in this type of data can be made by drawing conclusions using central tendency measures like mean, median, and mode dispersion or spread of data, that is range, minimum, maximum, quartiles, variance, and standard deviation, and by using frequency distribution tables, histograms, pie charts, okay, frequency polygon, and bar charts. So this is about the univariate. So you can see the example is height of students. The patterns can be studied by drawing conclusions using mean, median, mode, dispersion, or range, minimum, maximum, etc. So this is the meaning of univariate. So it consists of only one variable, and the analysis of univariate data is the simplest form of analysis since the information deals with only one quantity that varies. It does not deal with causes or relationships. The main purpose of this analysis is to describe the data and find patterns that exist within it. The pattern description found in this type of data can be made by drawing conclusions using mean, median, and mode dispersion or spread of data, that is range, minimum, maximum, quartiles, variance, and standard deviation. Next is bivariate. The bivariate data consists of two different variables. The analysis of bivariate data deals with causes and relationships. The analysis is done to find out the relationship between the two variables. Thus, bivariate data analysis involves comparisons, relationships, causes, and explanations. These variables are frequently plotted on x and y axis on the graph for better understanding of data. And one of these variables is independent while the other is dependent. Okay, so such examples like linear regression is a kind of bivariate data where we have one input and one output. So it together makes two variables there, right? So the bivariate data consists of two variables. The analysis deals with causes and relationships. The analysis is done to find out the relationship between the two variables, and thus bivariate data analysis involves comparisons, relationships, causes, and explanations. These variables are frequently plotted on x and y axis on the graph for better understanding of data, and one of these variables is independent while the other is dependent. Finally, multivariate. The multivariate data consists of three or more variables. It is comparable to bivariate but contains more than one dependent variable. The ways to perform analysis on this data depends on the goals to be achieved. Some of the techniques are regression analysis, path analysis, factor analysis, and multivariate analysis of variance. Okay, so this is about the univariate versus bivariate versus multivariate analysis. The next question, what are the feature selection methods used to select the right variables? So what are the feature selection methods? So what does this mean? To select the right variables. So there are two main methods for feature selection. One is filter and wrapper methods. So let's understand them. So when building a machine learning model in real life, it's almost rare that all the variables in the data set are useful to build the model. Adding redundant variables reduces the generalization capability of the model and may also reduce the overall accuracy of a classifier. Furthermore, adding more and more variables to a model increases the overall complexity of the model. The best explanation to a problem is that which involves the fewest possible assumptions. Thus, feature selection becomes an important part of building machine learning models. So the goal of feature selection in machine learning is to find the best set of features that allows one to build useful models of studied phenomena. The techniques for feature selection in machine learning can be broadly classified into supervised techniques, unsupervised techniques. So from a taxonomic point of view, these techniques are classified under filter methods, wrapper methods, embedded methods, hybrid methods. Okay, so let's see, what do you mean by filter methods? Filter methods pick up the intrinsic properties of the features measured via univariate statistics instead of cross-validation performance. These methods are faster and less computationally expensive than wrapper methods. When dealing with high dimensional data, it is computationally cheaper to use filter methods. So examples are information gain, chi-square test, Fisher's score, and so on. The second category is wrapper methods. Wrappers require some method to search the space of all possible subsets of features, assessing their quality, by learning and evaluating a classifier with that feature subset. The feature selection process is based on a specific machine learning algorithm that we are trying to fit on a given data set. It follows a greedy search approach by evaluating all the possible combinations of features against the evaluation criteria. The wrapper methods usually result in better predictive accuracy than filter methods. Okay, so some of the examples are forward selection, backward elimination, okay, exhaustive feature selection, and so on. Then we have another category called embedded methods. So these methods encompass the benefits of both wrapper and filter methods. So these are the different types of feature selection methods. Okay, so we discussed filter methods and wrapper methods. So you are given a data set consisting of variables with more than 30% missing values. How will you deal with them? Okay, so this is regarding handling the missing values. Okay, so if the data set is large, we can just simply remove the rows with missing data values. It is the quickest way. We use the rest of the data to predict the values. Or for smaller data sets, we can substitute missing values with the mean or average of the rest of the data using the pandas data frame in Python. There are different ways to do it. Okay, so the first way of handling missing values is to get rid of them. Okay, we will remove the rows or columns having the null values. So we use the drop NA function to just eliminate the rows or columns having the null values, but it is not a good solution. So the next and better solution is to impute the values into the null columns or null rows. So imputation means substituting the null values with some other values. You can insert the minimum value of the column. You can insert maximum value of the column. So using the minimum function and the maximum functions. Or if you want to impute a mean value, you can use the mean function to impute the mean value. All right. So this is how we deal with the missing values. It's not a good solution to just remove the columns or the rows having the null values. All right. So we have to come up with imputing the null values. So there are different ways to handle the missing values. Okay. So as I said, the deleting the rows, which is commonly used to handle the null values. Here we either delete a particular row or a particular column if it exceeds the threshold of missing values. And this is advised only when there are enough samples in the data set. One has to make sure that after we have deleted the row, we have deleted the data, there is no addition of bias. Okay, removing the data will lead to loss of information, which will not give the expected results while predicting the output. Or we will replace the null values with mean, mode, or median values. So this strategy can be applied on a feature which has numeric data like the age of a person or the ticket fare. We can calculate the mean, median, or mode of the feature and replace it with the missing values. This is an approximation which can add variance to the data set, but the loss of the data can be negated by this method, which yields better results compared to removal of rows and columns. Replacing with the approximations are a statistical approach of handling the missing values. This method is called as leaking the data while training. Another way is to approximate it with the deviation of neighboring values. This works better if the data is linear. Okay, so these are the techniques of handling the missing values. The next question is, what are the dimensionality reduction and its benefits? So dimensionality reduction is a topic we are familiar with, what is dimensionality and what is a reduction, right? So if we have worked on a data set with more than 1,000 features, how about over 50,000 features? It will be a very challenging task, especially if you don't know where to start with. Having a high number of variables is both a plus point and a negative point. It's great when we have loads of data for analysis, but it is challenging due to its size. So using dimensionality reduction techniques, what we can do, since it is not feasible to analyze each and every variable at a microscopic level, it might take us days or months to perform any meaningful analysis, and we will lose a ton of time and money for our business. Not to mention the amount of computational power this will take. We need a better way to deal with high dimensional data so that we can quickly extract patterns and insights from it. So using the dimensionality reduction techniques, we can reduce the number of features in your data set without having to lose much information and keep the model's performance. It's really a powerful way to deal with huge data sets. So this is what the dimensionality reduction means and what are the benefits of. So the benefits of applying dimensionality reduction to a data set are: space required to store the data is reduced as the number of dimensions come down. Less dimensions lead to less computation or training time. Some algorithms do not perform well when we have large dimensions. So reducing these dimensions need to happen for the algorithm to be useful. It takes care of multicollinearity by removing redundant features. For example, you have two variables, time spent on treadmill in minutes and calories burnt. These variables are highly correlated, as the more time you spend running on a treadmill, the more calories you will burn. Hence, there is no point in storing both as just one of them. It helps in visualizing the data. Okay, so it's very difficult to visualize data in higher dimensions. So reducing our space to a 2-dimension or 3-dimension may allow us to plot and observe patterns more clearly. So this is about the dimensionality reduction and its benefits. The next question: how do you deploy? How should you maintain a deployed model? Okay, so the steps are monitor, evaluate, compare, and rebuild. Okay, when we are ready to deploy a good predictive model, which given a good accuracy score on training and testing data set, there is one problem to solve. How long will this model effectively solve the problem with the same high accuracy, and what is the strategy to maintain the model accuracy? So we also need to know what action we need to take when the model's effectiveness on the decline trend. Okay, so how you maintain a deployed model? So you can see we have to monitor, evaluate, compare, and rebuild. So monitor in the sense we have to constantly monitor the models to determine their performance accuracy. So when you change something, you want to figure out how your changes are going to affect the things. So this needs to be monitored to ensure it's doing what it's supposed to do. Then we have to evaluate. Evaluation metrics of the current model are calculated to determine if a new algorithm is needed. Then we compare. The new models are compared to each other to determine which model performs the best. Then finally, rebuild. The best performing model is rebuilt on the current state of data. The next question: what are the recommender systems? Very important and very practical technology. The recommender system predicts what a user would rate a specific product based on their preferences. It can be split into two different areas. So the collaborative filtering. So there are two types in recommender systems. One is collaborative filtering and other one is content-based filtering. As an example, some shows recommends track that other users with similar interests play often. This is also commonly seen on Amazon. After making a purchase, customers may notice that the following message accompanied by the product recommendations: users who brought this also brought. Correct? So when you buy an item, it will show a list of items where the people, other customers, when they buy the same item, what other items they buy. So it's the recommendation for you. Correct? Then the other one is content based filtering. So as an example, some platforms uses the properties of a song to recommend music with similar properties. Here we look at content instead of looking at who else is listening to the same kind of music. Okay, so these are the two types of recommenders. Okay, so collaborative filtering versus content based filtering. So the content-based filtering makes recommendations based on user preferences for product features, whereas collaborative filtering mimics user-to-user recommendations. They can mix the features of the item itself and the preferences of other users. So the advantages of collaborative filtering are other users' scores are used and no deterministic result since chance is involved in the system. And the disadvantages are it needs more data. The it's a problem with new users and new products. Whereas content-based approach, it works with less data, provides results based on the activities of the specific users. The drawback is overall specialization. Okay. Then finally, how do you find RMSE and MSE in a linear regression model? As we know that linear regression is a supervised learning. We have simple linear regression and multiple linear regression. And this RMSE and MSE, you can see the formula. MSE equals summation of predicted values minus actual values, okay, divided by n, the whole square of the numerator. So mean square error and root mean square error. So if you want to make our model accurate, then we have to reduce this uh, value where the difference between the actual values and the predicted values is very minimum. Okay, so the MSE mean square error has the units squared of whatever is plotted on the vertical axis. The RMSE is directly interpretable in terms of measurement units and so is a better measure of goodness of fit than a correlation coefficient. One can compare RMSE to observed variation in measurement of a typical point. And there are also differences in the formula, how to find MSE and RMSE. So these are the two most common metrics used to measure accuracy for continuous variables. All right, so these are the two most common metrics used for measuring accuracy of continuous variables. Okay, so this was about MSE and RMSE. The next question, how can you select K for K-means? Okay, so K-means is a clustering algorithm which is a kind of unsupervised learning. Okay, so how can you select K for K-means? So there is a popular method known as elbow method, which is used to determine the optimal value of K to perform the K-means clustering algorithm. The basic idea behind this method is that it plots the various values of cost with the changing value of K. As K increases, there will be fewer elements in the cluster. So average distortion will decrease. The lesser number of elements mean closer to the centroid. So the point where this distortion declines the most is the elbow point. So this is one way, that is the elbow method, which we have discussed in our course. When we were solving the K-means, we have seen how to use the elbow method for this K-means algorithm. So K-means algorithm is simple and perhaps the most commonly used algorithm in clustering. So the basic idea behind K-means consists of defining the K clusters such that total within cluster variation is very minimum. Okay, so a cluster center is the representative of its cluster. The squared distance between each point and its cluster center is the required variation. The aim of K-means clustering is to find these K clusters and their centers while reducing the total error. So we saw the elbow method. The another one method is the Silhouette method, which we have also used it when doing the K-means. The Silhouette value measures how similar a point is to its own cluster compared to other clusters. The range of Silhouette value is between +1 and -1. A high value is desirable and indicates that the point is placed in the correct cluster. If many points have a negative Silhouette value, it may indicate that we have created too many or too few clusters. So these are the ways of selecting the K for K-means. All right. So these are the questions for this session. Any queries you can write to us. All right. Thank you.